Unit 3 Chemistry, Chapter 1, Part 3. Now we're looking at our renewable sources. We're looking at our biochemical fuels. So renewable, remember, that means we can replace them as rapidly as we are using them. All of the biochemical fuels, the way we can replace them is by using photosynthesis. Yeah? Because a biochemical fuel is made from organic matter, from a growing plant, essentially. And when that plant grew, it took in carbon dioxide and water, and it converted the sunlight into chemical energy in the form of glucose. And it made some oxygen, of course, which is useful for us to stay alive, but not useful in the context of biochemical fuels. The first of those fuels we're going to look at is bioethanol. Now, ethanol is made when a plant or yeast breaks down glucose without oxygen present, which is what we mean when we say anaerobically. And it makes two products. It makes ethanol and carbon dioxide. Now this ethanol here, it's no different from if we made ethanol from a source which came from crude oil. Chemically, it's called bioethanol just because it's made from a plant. Okay? This reaction is catalyzed, sped up by enzymes. Okay? And it's a reaction that humans have been exploiting for years to make bread rise, where we make the carbon dioxide is our useful product, for fermentation to make beers. But we can go a bit further than that, and we can force it by extracting the sugars and concentrating them a bit more to get a much higher ethanol concentration. And then we can use a process of distillation to separate out all the stuff we don't want and dehydrate it to get rid of all the water and to get an almost pure ethanol product. Okay. Once we've made it, okay, there's a few things we can do with it. So we'll make it in all of these tanks. Don't worry about all the steps, you don't need to know about that. Okay. This step here, this is where we're having our fermentation tank. Okay. The carbon dioxide we'll sell it and put it into carbonated drinks. Okay. The ethanol, once we've purified it, we can use it directly as a fuel. Now, in Australia, if we're going to use it directly as a fuel, we do add 5% petrol to it. We'll come to that later. The other thing that's really useful to make bioethanol is we don't have to use sugars, we don't have to use glucose. And we might not want to use glucose because glucose has got a lot of other uses, as a food predominantly. But we can use the byproducts. Okay? We can use this xylose. Now xylose, this one's glucose, that one's xylose. They've got very similar structures. If we can digest this and use that to make ethanol, we've got a couple of advantages there. Either we're just making use of a waste material, because this would otherwise be thrown away, or if we're using both, then we're increasing the amount of bioethanol we can make. So we're increasing what's called our yield. Okay. There's also some people who are exploring using the cellulose, which makes up plant cell walls. Okay. And if we can use that as well, again, we're going to increase our yield because more of the plant's chemical energy is going to get converted into ethanol, and therefore we can use more of that energy as a fuel source. So the primary use of bioethanol is as a fuel. If you want to run a car directly off bioethanol, you've got to convert the engine. You've got to change the engine. You can't just take your normal car and put ethanol in and expect it all to be good. Okay? As I said before, we add 5% petrol to it. That's to stop people drinking it. If you just had ethanol at a petrol station, some people, not you, but some people might go and fill up a jar and try and drink it. Okay? And drinking pure ethanol it's a poison, so it would kill you. Okay? So they add the petrol to dissuade people from taking such a silly course of action. What's more normal though is that you'll find E10 petrol, or sometimes E5, but E10's more common. That's 90% petrol, 10% bioethanol. So we're only getting 10% of it from a renewable source, but 10% is better than none. The other useful biofuel is biodiesel. Now biodiesel is an ester. Remember esters from year 11? Yeah? We take vegetable oil and an alkanol. So here we've got the vegetable oil, which is actually composed of fatty acids. And those fatty acids were reacted with glycerol. We get rid of that. And we react them with methanol instead. So remember, we make an ester from the reaction of a carboxylic acid and an alkanol. Yeah? By doing that, we have a condensation reaction. Condensation because we're removing water. And we make that ester group. Okay? So, here is our oil at the start. Remember we said it was bonded to glycerol? Well, that's it there. Okay? This R1, R2, R3, that's your fatty acid side chains. What we can do is add 3 methanols, add a catalyst, and what we're going to do is we're going to break off this bit here, the glycerol, and we're going to add this bit here in its place, removing the water as we go. Okay? So we get 1, 2, 3 molecules of biodiesel as our desired product, and then we get glycerol as our waste product. Glycerin is an old-fashioned name for glycerol. Now, biodiesel is, again, commonly used as a fuel, so B5 or B10, yeah, which gets put into a normal diesel mix, and B5 means it's 5% biodiesel, B10, 10% biodiesel, and we can put that in, okay? It's generally made from sort of recycled fats and oils, yeah, and it has very similar properties to petrodiesel, so it can be used for the same purposes. So normally you'd use it for transport. And remember, transport is our biggest energy use, so it's very important. If we can replace some of these traditional fuels, then we're really reducing our reliance on fossil fuels and increasing our reliance on things which are renewable that we can replace, because we can always grow more plants. The third biofuel that we'll look at is biogas. Now, biogas is a way of making methane. Okay, so it's going to replace any natural gas, in theory. If we decay organic material in the absence of oxygen, it's going to make methane. Okay? It's very commonly used in farms where they have a lot of rotting manure, so they're just going to pile it all up, let the methane be produced, and then they can burn it for heating. Okay? It does also occur, we sometimes get a methane build-up at landfills. At the moment that's normally seen as a problem, but if we could harness that methane and put it to a useful use, then it wouldn't be seen as quite a problem and it would be less polluting letting methane out into the environment. The advantages of biochemical fuels, why use them? Well, number one, we're reducing how much we're using fossil fuels. Number two, they're considered to be carbon neutral. Now, that doesn't mean that they don't give out any carbon dioxide when you burn them. They do, of course they do. Okay, you've got carbon in there, you react it with oxygen, it's going to give out carbon dioxide. But remember where they came from. They came from a plant that photosynthesized. And when that plant photosynthesized, it took in carbon dioxide. So any carbon dioxide that's given out is only sort of replenishing how much carbon dioxide was originally taken in by the photosynthesizing plant. Okay? They also tend to make use of things that would otherwise be waste products. So from that point of view, they're also a desirable product. Problems? Number one, they're not truly carbon neutral because there is energy used in the production. The other big problem, we need land to make food. We've got a hugely growing worldwide population of humans. If we take that land and say, well, we're going to use all that land to make bioethanol or biodiesel, then we are possibly removing this food source stability, particularly for some people in developing nations. And at the moment, it's kind of tinkering around the edges. We're putting 5 or 10% of a biofuel in with diesel or petrol. Okay? At the moment, that's not a huge amount, so it's not going to make a big difference unless we start converting cars to run on more than that small amount.